Let's see if we can figure out what the empirical formula of this compound is from this unit cell. Notice in this unit cell we have a mixture of copper and oxygen atoms. The oxygen atoms are the red ones and the copper atoms are the brown ones. So this first question is asking us how many copper atoms are in this unit cell. Pause the video, take a moment, see if you can come out with how many copper atoms are in this one cell. Okay, hopefully that worked and you got a number. I know when I first started looking at diagrams like this, it was a little confusing initially to interpret these. Let's talk about where all these atoms are positioned so we can figure out what the copper atom positions are and therefore how they contribute to the unit cell. So the red oxygen atoms sit on all 8 corners. So all 8 corners have a red oxygen atom, and the absolute middle of this cube has an oxygen atom sitting in it. The copper atoms are sandwiched between that center. Let me switch to the highlighter or laser pointer. Yeah, you didn't switch. Can we try that again? Okay, why are you not letting me select that? We'll try again. Oh, there it is. So this atom is right at the absolute 3-dimensional center of the cube, and then this atom, the copper atom, is sandwiched between the body center and the corner. So this copper atom actually ends up being entirely within the unit cell. We can make that same argument for all 4 of these coppers. All 4 of those coppers are sandwiched between the center oxygen and a corner oxygen. So the coppers are all body atoms, and so we have 4 of them, and the body atoms completely are within the unit cell, so we end up with a total of 4 copper atoms. On the next slide, it's going to ask us about the oxygens. The oxygens are a little more complicated because they're in 2 positions. We have 1 oxygen atom that's a body center, and so it contributes completely to this unit cell. And then we have 8 oxygen atoms that are located in the corner positions, so they each contribute 1/8. So that's going to be 1 plus 1, or 2. There are 2 oxygen atoms in this unit cell. So our next question is, what is the formula of this compound? Well, when we write formulas, we put the least electronegative element first and the most electronegative element last. So copper is farther from fluorine than oxygen is, so copper goes first, followed by oxygen, and then there are 4 coppers and 2 oxygens. Now remember, at the very beginning of this section, we talked about empirical formulas. Since this is an ionic compound, we absolutely want to report the empirical formula, which means that smallest whole number ratio. So 4 and 2 can both be divided by 2, so we want to reduce it. And we're going to end up with Cu2O for our empirical formula based on that unit cell. On a quiz or a test, I'm going to be asking you for that empirical formula. All the work we did up to there is like the work for how you get to that answer. But on the quiz or a test, it's that final empirical formula you'll need to be able to find. So remember to reduce if you need to. All right, so here's another example. We've got strontium, oxygen, and titanium in this unit cell. I want you to take a moment and see if you can figure out the strontium atoms, the titanium atoms, and the oxygen atoms, and then how would we write the unit cell. So go ahead and pause the video and take a moment to figure that out. All right, hopefully you paused, you took a moment to figure out the atoms in this unit cell. So let's start with the strontium. Those are the green atoms. When I'm looking at the strontiums, it looks like all 8 corner atoms are strontium. So we have 8 atoms, and since they occupy a corner, 1/8 of each atom is contained in that unit cell. So there's going to be one strontium atom in each unit cell. Now let's take a look at the next slide and find one of the other elements. All right, let's take a look at the titaniums. There is one titanium in here. I'm trying to circle it. It is smack dab in the middle of this unit cell. So it is entirely within the unit cell, and there will be one titanium. All right, let's tackle oxygen. All right, so for oxygen, it looks like each one of these oxygens is in the center of the face of the crystal unit cell. This would be like the dot on a die for the 1, or you might even think of it as the dot in the center on the 5. This is just a dot that's right smack in the middle of this face. And all 6 faces have one. So there are 6 of these oxygen atoms. Because they're on a face, half of the atom is in the unit cell. And so that means that we have 3 oxygen atoms in the unit cell. All right, let's take a look at the next slide to do the empirical formula. Okay. If we're going to write the empirical formula, we want to go least electronegative to most electronegative. So we have strontium, followed by titanium, followed by oxygen. For the strontiums, we decided that was a 1. And for the titaniums, that was also a 1. And then for the oxygens, that was a 3. So cleaning that up, final answer, SRTiO3. My power just blinked. For reference, this is February 1st, 2023, and we are actually off of school today because of an ice storm. Lots of my colleagues who live fairly close by don't have power at the moment, but we still do. So the power blinking is a little, well, I guess I just need to finish this video real fast, right? Okay, let's go on to our next example. All right, so with this one, this is what you will see on a quiz or a test. The question will just say, what is the formula of this compound? So you have to go through that whole process that we just went through, where you look at each one of the elements, you figure out how many atoms of that element are in the unit cell, and then we find the smallest whole number ratio between them. Pause this video, figure out what the empirical formula is, and then come back and turn the video back on and see that you got it right. All right, pause. And here we go. Let's figure out what the correct answer here is. If we are going to write our formula, we're going to put strontium first, followed by iron, followed by oxygen. That's just going in the order of farthest away from fluorine all the way to closest to fluorine, right? Because the most electronegative is last. For strontium, strontium's the silvery one or gray one. There's only one of them, and they're trying to show that's just absolutely in the middle of the cell, so it's entirely there. We have one strontium atom. Iron is the small orangish, brownish, rust-colored atom, and it looks like we have irons. There are iron atoms at all 8 corners. So we have 8 iron atoms, each contributing 1/8, which gives us 1 atom per unit cell. And then last but not least, with the oxygens are located along the edges of the top and the bottom of this unit cell. There are a grand total of 4 up top and 4 down below, so there are 8 of, whoops, I should label this for oxygen. There are 4 up top, 4 down below, which is 8. Edge atoms are shared by 4 unit cells. So 8 times 1/4 gives us 2 oxygens. So cleaning this up and rewriting it, we end up with SrFeO2. There we go. And so that's what would be asked on a quiz or a test, but you have to go through that whole process in order to reach that final answer. And that's it, folks.